Welcome to Astronomy Daily, your daily fix of the latest space news and discoveries. I'm Anna, and today we have a fascinating lineup of stories to share with you. We'll explore Earth's newly named Quasi Moon, witness breakthrough observations of black hole jets forming in real time, and discover an innovative concept that could revolutionize interstellar travel. We'll also look at Europe's ambitious plans for Mars exploration and catch up with an exciting lunar mission currently making its way to the moon. Plus, we'll preview an upcoming partial solar eclipse that many of you will be able to witness in March. So let's get started on our eclectic mix of stories. In a delightful blend of ancient mythology and modern astronomy, one of Earth's mysterious quasi-moons has finally received its official name. Previously known by its rather clinical designation 2004 GU9, this celestial object has been christened Cardea after the ancient goddess of door hinges. Really. The name was chosen through a contest organized by the International Astronomical Union and the popular science podcast Radiolab. Clay Chilcutt, a student at the University of Georgia, submitted the winning name as part of an extra credit assignment for his astronomy class. His choice perfectly captures the unique nature of quasi-moons, which exist in a fascinating state between being true moons and independent asteroids. Unlike regular moons that orbit planets directly, quasi-moons actually orbit the sun while appearing to circle Earth from our perspective. The name Cardea is particularly fitting because, like a door hinge that connects two spaces, these quasi-moons occupy a transitional space in our cosmic neighborhood. They're not quite moons, not quite asteroids, but something in between. Cardea, as the goddess who presided over thresholds and transitions in Roman mythology, beautifully symbolizes this celestial gateway between Earth and space. The contest featured other compelling entries drawing from various mythologies worldwide, including Bakunawa from Filipino mythology and Tariaksuk from Inuit tradition. But it was Cardea that captured the imagination of the distinguished panel of judges, which included theoretical physicist Sean Carroll, astrophysicist Wanda Diaz-Merced, and even Bill Nye, the science guy. This naming marks another fascinating chapter in our understanding of Earth's cosmic companions, joining Kamo Owalewa as one of the few named quasi-moons in our planet's vicinity. These objects, while not true satellites of Earth, remind us of the complex and often surprising ways celestial bodies can interact with our planet. Next up, you guessed it, today's black hole discovery. In an extraordinary astronomical breakthrough, scientists have witnessed something never before seen in human history: the real-time formation of plasma jets shooting from a supermassive black hole. This remarkable event occurred 270 million light-years away in the constellation Draco, where astronomers observed a galaxy known as 1ES 1927 plus 654. The story began in 2018 when this distant black hole started behaving unusually. Its X-ray corona mysteriously vanished, followed by a dramatic increase in brightness across multiple wavelengths. But what happened next left astronomers completely stunned. The black hole's radio emissions suddenly increased 60-fold over just a few months, and researchers watched as massive plasma jets formed at both poles of the black hole. Using the Very Large Array and Very Large Baseline Array, scientists captured high-resolution images showing these jets expanding outward between 2023 and 2024. These plasma streams are moving at roughly 20 to 30% of the speed of light, an astonishing velocity that demonstrates the incredible power of these cosmic phenomena. While astronomers have observed larger jets from other black holes before, some extending hundreds of thousands of light years, this observation is particularly special because it's the first time we've watched one form in real time. These smaller, shorter-lived jets, known as compact symmetric objects, may actually be more common throughout the universe than their larger counterparts. The team believes these jets might have formed when the black hole consumed a star or gas cloud, providing valuable insights into how black holes interact with their surroundings. While many questions remain about exactly how these jets form and what powers them, this unprecedented observation brings us one step closer to understanding these mysterious cosmic processes. The discovery opens up exciting new possibilities for studying how supermassive black holes influence their galaxies and the broader universe. Scientists will continue monitoring this remarkable system, hoping to unlock more secrets about one of space's most enigmatic phenomena. Now, let's take a trip into the realm of what many would have considered science fiction a short time ago. In what could be a game-changing development for space exploration, researchers have proposed an innovative new method of interstellar travel that could dramatically reduce journey times to other star systems. The concept revolves around using relativistic electron beams, streams of electrons accelerated to nearly the speed of light, to propel spacecraft across the vast distances of space. The fundamental challenge of interstellar travel has always been generating and transferring enough energy to spacecraft efficiently and affordably. Current chemical rockets, even with gravitational assists from planets and the sun, simply can't achieve the speeds necessary for practical interstellar missions. But this new approach could change everything. The proposed system would use a beam-generating spacecraft positioned near the sun, taking advantage of intense solar energy to power an electron beam accelerator. These high-speed electrons would then be directed at the spacecraft, providing continuous propulsion over vast distances. What makes this concept particularly fascinating is how it handles one of the biggest challenges, keeping the electron beam focused over such enormous distances. At relativistic speeds, time dilation actually works in our favor, giving the beam less time to spread out. Additionally, the natural plasma present in space creates a magnetic field effect that helps keep the beam concentrated, similar to what we observe in jets from black holes. This relativistic pinch effect could maintain beam coherence for thousands of times the distance from Earth to the Sun. The numbers are incredibly promising. Calculations suggest this system could accelerate a 2,200-pound probe, about the size of Voyager 1, to 10% of the speed of light. At that velocity, we could reach Alpha Centauri in just 40 years, compared to the current 70,000-year journey time. Even more encouraging, this approach could be significantly more cost-effective than alternatives like laser propulsion, while capable of moving much larger spacecraft. While significant engineering challenges remain, particularly in converting the beam's energy into propulsion without melting the spacecraft, this concept represents one of our most promising paths toward making interstellar exploration a reality within a human lifetime. The European Space Agency is setting its sights on an ambitious new chapter in Mars exploration, with plans to develop advanced landing technologies for a mission targeted to launch in 2035. While the agency is currently focused on sending the Rosalind Franklin rover to Mars in 2028, they're already looking ahead to tackle even greater challenges. The new initiative calls for the development of guided entry landers with high-precision landing capabilities. ESA is getting an early start on this project, recognizing that 2035 presents the most favorable launch window of the decade for reaching the red planet. The timing of this development is crucial, with key decisions expected at an upcoming ministerial meeting in Bremen later this year. Meanwhile, in current lunar exploration news, Firefly's Blue Ghost lunar lander is making excellent progress on its 45-day journey to the moon. The spacecraft, carrying 10 NASA scientific instruments, has successfully completed its first main engine burn, marking a crucial milestone in its mission. The journey plan is quite intricate. Blue Ghost will spend 25 days orbiting Earth before embarking on a 4-day transit to lunar orbit, followed by 16 days circling the moon before attempting its landing. One of the mission's most impressive achievements so far comes from the Lunar GNSS Receiver Experiment, or LUGRA, which has already set a new record. The system successfully calculated its position using Earth-based navigation signals at a distance of more than 205,000 miles from Earth. That's about 90% of the way to the moon. This breakthrough suggests that conventional GPS-style navigation could be viable for future deep space missions. The spacecraft has also captured some breathtaking footage during its journey, including spectacular views of Earth eclipsing the sun. These early successes bode well for both the immediate mission objectives and our broader understanding of lunar navigation and landing technologies. Mark your calendars for March 29, 2025, when skywatchers across the northern hemisphere will be treated to a remarkable partial solar eclipse. While we won't see a total blackout of the sun, this event promises to be quite spectacular, with up to 94% of the sun's disk being blocked by the moon in some locations. The eclipse will be visible from 8:50 to 12:43 UTC, with the best views coming from eastern North America and parts of Europe. If you're in far northern Quebec, you'll be among the lucky few, just about 44,800 people, who'll witness the moon covering 90% or more of the sun. For viewers in New Brunswick and Maine, the show will be particularly dramatic, with the partially eclipsed sun rising as two distinct horns on the eastern horizon. Across the Atlantic, Europe will get varying views of this celestial spectacle. The British Isles will see a fairly deep eclipse, with Dublin experiencing 41% coverage and London about 30%. As you move eastward, the eclipse becomes progressively smaller, with Paris seeing 23%, Berlin 15%, and Moscow just catching a glimpse with 2% coverage. Northwest Africa will also get to participate in this event, though to a lesser extent. The best views will be from Morocco's coastal regions, where cities like El Jadida will see about 18% of the sun covered. Remember, no matter where you're viewing from, proper eye protection is absolutely essential. Never look directly at the sun during an eclipse without certified solar eclipse glasses. This event will kick off a series of partial solar eclipses stretching through the rest of the decade, with the next one visible from Tasmania and New Zealand in September 2025. It's a reminder of the constant dance between the sun, moon, and Earth that brings us these fascinating astronomical events. This has been Astronomy Daily. I'm Anna, and thank you for joining me on this cosmic journey through today's space news. Whether it's quasi-moons, black hole jets, or the promise of faster interstellar travel, there's always something fascinating happening in our universe. If you'd like to catch up on any of our previous episodes or dive deeper into the stories we've covered today, head over to astronomydaily.io. You'll find our complete archive of episodes there, along with additional resources, links, and information about all the topics we discuss. Stay connected with us on social media by following Astro Daily Pod on Facebook, X, Tumblr, YouTube Music, and TikTok. We're always sharing the latest updates and engaging with our community of space enthusiasts. Until tomorrow, keep looking up and wondering about the mysteries that await us in the cosmos.